with us our resource person, Dr. Kannan, who is the assistant professor and research supervisor of Ayyanadar Janaki College, Sivagasi. He is the Young Research Award and Research Excellence Award and Dedicated Service Award winner. He is also having life membership of many mathematical societies. He published many national and international journals and also chapters in many of the mathematical books. We are going to see next topic of aptitude skills today. Welcome you, sir, and over to you, sir.
Thank you, ma'am. Thank you for a nice introduction.
Thank you, sir.
Good afternoon to all of you. First of all, I thank given to the opportunity for the founder of college and all the principal and the vice principal and the coordinators, program coordinators, and all the faculty members and my dear students, all of you, good afternoon. In connection with the national webinar on guidance of aptitude skills for competitive examination, today is a second session. Actually, yesterday discussed only for a ratio proportion variation, but today some other topic in aptitude, some most important. The title is time and work, because time and work needed zero formula. Then only it is very easy level aptitude topic. Time and work need zero formula, but solving all the problems only logically. And sometimes some mathematical ideologies to help with the solving problems. Then only it possible to you got a full mark. So RRB, IBBS, GMAT, GET, all the exams, time and the questions contained in time and work topic. So today discuss time and work topic. So now I share my screen. Okay. So today topic is a time and work. Actually, the time and work, the ideology, just to introduce the ideology. Next, to go to the topic and discuss the problems. Time and work. What is the connection with the time and work? Any problem given in the title. First of all, the problem based on work. Also, the condition given by particular time. The asking question also same type of work and problem time. So how to handle this type of problem? So no need any formula, but just only two things. You need just two things only. All the problems in the title you have to attend. You have to attend the time and work problem and get the full mark definitely. So first one, suppose person A can complete a work in 8 days. What type of work? Any work, but take 8 days. Complete a work in 8 days. Person in A. So how to relate with the days and efficient or work? So the work is completed in 8 days. So first day completed in 1 by part of work. Second day completed in 1 by 8 of work, part of work, and so on. 8 days, 8 days, 1 by 8 part of work. So given in a given information is in terms of days, but we can convert how much work in completed in 1 days. So suppose the work is completed in n days, then how part of the work completed in 1 day? Simple, just 1 by n. Suppose a person completed in a work within 10 days, then how part of the work completed in 1 day, then just 1 by 10. It is a part of work or efficient anymore. Suppose some other person the same work completing work in 20 days, then 1 day completing work is a 1 by 20 part of the work. So efficient wise A is greater because the ratio says just multiple by 20, then 2 is to 1. So efficient of A is greater, but the days of A smaller than comparatively B. So any problem given that in the title, just convert in part of work, days to part of work. Then only you are proceed any proceed by problematically. So it is a first thing. Second thing is suppose same work or different work, comparing two type of data. Suppose employees M1, number of days D1, number of hours in per day H1, work W1, some other number of employee, some other number of days, some other work divided by some other. Here W1 W2 same or different, it's not a problem, but the ideology is how to conclude the procedure, how to relate two type of data, connecting with the two type of data: number of employee, number of days, number of hours working in per day. So work, so W1 W2 may be equal, may or not equal, no problem. It's data. Suppose some problem given all the data, some problem given only number of employees, number of days only, some problems not given in number of hours, no problem. So yeah, whenever give number of hours per day, then applying the concept. Otherwise, just relax. Yeah, just relax with the M1 D1 divided by W1 equal to M2 D2 divided by W2. Suppose W1 and W2 is same, then the W1 equal to W2, then cancelling two terms only for numerator only, for equating to numerator only. So it's only two things, very important. Only two things, you will get all the problem perfectly correct. So now move to the problem number 1. Actually the problem is 24 men takes 20 days to complete a piece of work. In how many days can 15 men complete the work? So here the work is same but not given. In the situation, assume that the work is same, because 24 men take 20 days to complete a piece of work, but here not giving the complete the work, but the work is same or not giving. In this situation, two works are same. Therefore in the previous situation, W1 and W2 same, and also number of hours not given in the problem. Therefore only using for this type of format. So only number of employee and number of days only. So now W1 and W2 is same, therefore denominator need not be considered. So here 24 men number of employee and they take 20 days. So M1 into D1 equal to how many days can 15 men complete the work? So 15 men, how many days? So D, same work, therefore W1 so will be cancelled. Therefore just so 20 is 4 times, just 3 times, and cancelling 3, just 8 times. Therefore just 32 days only. So D is number of days, because 32 days can 15 men complete the work. just one line answer. Only you need to this type of format. It's not a formula, just a format. W1, W2, two type of work may be equal or not equal, but number of employee different, number of days may be different, number of hours may be different, given or does not given, no problem. Suppose given, using it this format. Suppose not giving that in the problem, then using this type of format. So first problem gives only number of employee, number of days only. Therefore 24 men takes 20 days can complete a piece of work, and 15 men, and 15 men, how many days can 15 men complete this work? So just applying t variable here. Suppose you need applying m, otherwise no problem, because just imagine. So 24 men into 20 days, take 20 days. So 15 men, how, how much day, how many days? Same work. Therefore just d equal to 32. So 15 3 times, so 4 times, cancelling 3 on both sides, 8 times. So d equal to 32. So answer is 32. So the now problem number 1 is very simple. So now go to the second problem. Actually the problem the answer is 32 days actually. So 24 men takes 20 days to complete a piece of work. In how many days can complete? 15 men complete the work. So just formatting to number of employee, number of days only. Work is same, so no problem. Very simple question. It is also asking to simultaneously in IB based question, banking sector. Problem number 2. Problem number 2 says that 54 men takes 15 days to complete a piece of work, working in 6 hours days, 6 hours a day. So here given just watching the data, number of employee given. So here number of employee and the number of days and the number of hours per day. So all the data given. In the situation, we need the first format only, because number of hours given. How many hours a day? The question is only for how many hours a day should the 30 men work to complete the work in 27 days. Actually 54 men, 15 days per day, 6 hours. Then 30 men in 27 days complete the work in how many hours a day will in the same work. So just H. So work is the same, because not giving in the form of not giving different work. Any time not giving different work, definitely we assume that the work is same. Otherwise nothing to problem. So here the format is the first format, m1 d1 h1 divided by w1 equal to m2 d2 h2 divided by w2. Here w1 w2 is same, and m1 is given, m2 d1 is given, h1 is given, m2 given, d2 given, but h2 is asking in the second problem. So just cancelling this part and we'll get immediate answer. So 27 cancelling 27, so 2 times. So cancelling 15 2 times. So cancelling 2, and just h equal to 6 hours. So here also 6 hours per day. And one more thing, suppose you are logically very strong, then just think about 54 into 15 into 6 equal to 30 into 27 into some h. Here just focus on two terms. Here 15 into 2 into 27. 2 into 27 actually 54. So 15 into 54, 15 into 54 same. Therefore h equal to 6, no problem. So the problem is identifying that some ideological is very essential for them, because 54 into 15 into 6, how to match the numbers in the previous part. So 30 into 27 into H. So how to split in the numbers 15 into 2 into 27. So just splitting the numbers. So here 2 into 27 is 54 because 15 into 20, 54 is already left side. So 15 into 54. Therefore, H must be 6. So very simple, but logically you are very strong, then definitely you will get this way of answer. But always I appreciate this type of answer because it's sometimes it's maybe 10 seconds or 12 seconds may be needed, but just watching this problem, uh, click the answer only for just 5 seconds or 6 seconds. So the second problem, the answer is 6 hours. So check the answers. So first option 6 hours per day. So third problem, just focusing the third column because the sentence is very high, because first column is 1.5 line, second column is 2 line, but third column is 2.5 line. A piece of work can be completed by 18 men in 12 days, working 6 hours a day. So data is given by number of employee, number of days, number of hours. How many men are needed to complete another work which is twice as greater as the first one? That means two works are not equal here. How many men are needed to complete another work which is twice as great as the first one? So in 9 days working 8 hours a day, so the data are 18 men, 12 days, 6 hours per day. Here is a W1. Now how many men? So M into 9 days into 8 hours per day, but the work is different. How much difference? Another work which is twice as great as the first one. So 2W1, because it's equal to W2, but W2 which is twice as great as the first one. So W1 is just W1, but twice as working W2. Just removing the variable, cancelling 2. So just cancelling 4. So 3 times, just cancelling 9 from here 2 times. So multiply by 3, 6 and 2. So answer is 36 equal to men. So 36, we need 36 men. So one more times explaining the problem. A piece of work can be completed by 18 men in 12 days, working 6 hours a day. How many men are needed to complete another work which is twice as great as the first one in 9 days, working 8 hours a day? Just forming the first format, number of employee, number of days, number of hours per day divided by work. But here the two works are different. The second work is twice as much as first one. So W1 and W2 W1. So W2 equal to actually 2 W1. So on the second part is how many men are needed to complete the another work which is twice as great as the first one. 9 days working 8 hours per day. So just 18 into 12 into 6 equal to M into 9 into 8 divided by 2W1. So all the time you need not be write the word W1, because W1 is just W1 W2 is the variable is same, because the second work is compared to the first work. Therefore just 18 and 12 and 6 divided by 1 equal to M into 9 into 8 divided by 2. Just not needed to W1 in any other variable. So cancelling 4 and cancelling 9 and multiple by all the numbers, we get the answer. So 36 your answer. So M equal to 36 men. The third problem nicely solved. So check the option. So option is 36 men. So problem number, go to the problem number 4. Problem number 4, actually, lot of humans, which place mathematics needed. Mathematics, how to use mathematics. This is a best example because very essential part in contracting scheme. Here, just reading the problem. 30 men were employed to complete a piece of work in 20 days, but they would complete only 20% of the work in 5 days. How many more men should be employed to finish the remaining work on time? So the question is very powerful in this word, on time. On time means the 20 days it's on time, but already 30 minutes. uh, just consider a contractor, a work assigned by a contractor, but the contractor assigned by employees 30 men, assigned by the work, but in completing the work in just 20 days, but after 5 days completing work only 20%. So 20% 5 days, another 20% 5 days, another 20% 5 days, another 20% 5 days, another 20% 5 days, because 100% complete. But the number of days is 25 days. It not used for my contract because my contract signed by 20 days only, but after 5 years will maybe fine. Therefore, after 5 days, the contractor assigned some extra manpower. So this only the question: how many more men should be employed to finish the remaining work on time? So therefore, the problem goes to very simplest form in the first form, because the second form, because number of cards not giving in the format. So how to format? So answer is second option. How to conclude the answer? Just watch. So first of all, after 5 days, completing work is 20%. Remaining work is 80%. So just 30 men, 5 days, completing 1 by 5, because 20% equal to 1 by 5. 20% means 20 by 100. So 20 by 100 is 1 by 5. So equal to, question is how many more men, but just calculating how many men we needed after totally 20 days, just 5 days finishing. So remaining days is 15, and the remaining work is 4/5. So just finding the answer M, and how much more than 30 men, it is the answer. So cancelling 1 by 5 on both side, and cancelling 5 by 5 on both side, and multiplying by and 3, cancelling 3 on both side, and multiply by 4. So M equal to 40. So after 5 days we need 40 minutes. Already 30 minutes assigned by 30 minutes. So extra member is, extra men is 10 members, 10 men. So extra 10 minutes only. So the answer is 10 men. So just second format, because number of work not giving the problem. So how to approach the problem? 30 men employed, already employed to complete a piece of work in 20 days. It is a contract. So after 5 days only completed 20%. So in this speed, the completing the work is definitely 25 days. Therefore, we assign some more men. How much men? This only the question. So just 30 men, 5 days, completing 1 by part of work. So how many men? 15 days remaining work. Remaining work means 80%. 80% means 4 by 5. Therefore, cancelling all the data, M equal to 40. So 40 means number of employees. But the question is how many more men should be employed? So how many more men's? Already 30 men's employed. More men's means 10 members extra. So the answer is 10. So very, very practical question. Practical real life problem. Actually very, very, very real life problem. It is a nice example for real life problem in mathematics. So go to the next problem. Actually, the problem is 3 men or 4 women. So the question is very carefully, reading very carefully. So the word are sometimes give and sometimes give are different, just partially differentiate the word and are. So here given by 3 men or 4 women can construct a wall in 62 days. How long will it take 12 men and 15 women to do the same work? To do the same work means construct a wall. So just proceeding that. So 4 men, sorry, 3 men, 3 men or 4 women. R means 4 women. So the efficient of 3 men equal to efficient of 4 men. It's the first observation. So the problem gives 3 men or 4 women can construct a wall in 60 days. 3 men construct a wall in 60 days. And also 4 women can construct a wall in 62 days. So efficient of 3 men equal to efficient of 4 women. It's the first observation. How long will we take 12 men and 15 women to the same work? So 3 men complete a work in 60 days. So same work, but now convert 12 men plus 15 women in terms of only for men or only for women. Here we'll take men, therefore the term W means the women's converted to men. How to convert? Simple. Actually the term 4W equal to 3M, therefore so actually we need 12 men plus 15 women equal to 4W equal to 3 men. So multiply by 4 on both sides. So 12 men equal to 16 women. Therefore, replacing the 12 men by 16 women. So 16 women plus 15 women equal to 31 women. So the problem is converted. Now the problem is converted. So 12 men and 15, and means plus 12 men and 15 women converted to 31 women. But the given data, 4 women construct a wall in 60 days. So the problem is 4 women construct a wall in 60 days. Therefore, how many 31 women, how many days will take the same work? So just D. Therefore, cancelling the data and 8. So the answer is just 8 days. So in the type of problems, read carefully because the wording is very, very important in the mathematics or any other aptitude question, because it's a skill based practices. So skill, how to approach, how to observe all the things in include all the things contained in the skill part. So 3 men or 4 women means 3 efficient of 3 men equal to efficient of 4 women. In construct a wall in same days. Actually 3 men construct a wall in 60 days. Also 4 men construct a wall in 60 days. How long will it take for 12 men and 15 women to do the same? That means here is here given by and operator. So 12 men plus 15 women means plus and. So we convert men and women is only for it is just for converted only for men or women, but we very easily to convert men to women because 4W, how to 4W equal to 15W, it's a very lengthy process. So just multiple by 4 on both sides. So 12 men equal to 16 women. So replacing the 12 men equal to 16 women. So 12 men and 15 women work equal to 31 women. So the problem is changed to 4 women consecutive all in 62 days. 31 women, how many days completing the same work? So days is 8. Just cancelling the part. So very, very simple problem, but very analyzing part is very tough because the word is are, and sometimes students printing mistake maybe asked to maybe told me printing mistake, but the problem is uh, not more than enough data because 3 men efficient of 3 men and efficient of 4 men is equal. uh, in the sentence says efficient of 3 men and efficient of 4 men is equal. So how to conclude the 12 men and 15 women? How many days complete the same work? It's only the problem. The answer is 8 days. So answer is okay. So next problem. Same type of problem actually. 8 men and 12 women can do a job in 10 days. And so it is the first sentence. And second sentence, 14 men and 28 women can do the same work in 5 days. How long will it take for 6 men and 8 women to the same work? Just a question. So just 8 men plus 12 women can do a job in 10 days. So completing what 10 days. So efficient is 1 by 10, or how part of work is 1 day, 1 by 10. And also 14 men plus 28 women equal to 5 days completing the work. So 1 by 5. But the answer is 6 men plus 8 women. How? Suppose 6 men plus 8 women equal to 1 by k. The answer is k days. Because efficient is 1 by k, or one part of working one days is 1 by k, then completing the work in k days, then only we conclude the k days. So now I leads to the two equation in the form of 6m plus 8w equal to 1 by k form. So how to do this the problem? So just watch. So just cancellation law or any other law using it and applying the problem. So or any other methods you can use it very shortly. Mostly the students are arts students using cancellation law because how find m and find w, applying the part, so we'll get the answer. So in the same way but lengthy way, but it's very basic way. So cancelling m, then so just multiplying 14. So 14 times 8 m plus 12 into 14 w equal to 14 by 10. Second step is just multiply by 8. So 14m plus 8 times 28 w equal to 8 by 10. Sorry, 8 by 5. So subtracting these two forms, definitely cancelling the first term. So 14 8, 8 into 14 cancelling. So how the term is remaining? Just watch it. 12 into 14 minus 8 into 28. So 12 into 12 into 14. So 12 into 14 minus. So second term is 8 into 28. So 8 into 28 w equal to just 14 by 10, 8 by 5. So 14 by 10 minus 8 by 5. So just here is 14 into 2. So 12 times 14, here 16 times 14. So subtracting two things, 4 times 14w. So 16 times 14, here 12 times 14. So therefore 4 times 14 w. Here is just 16 by 10 multiplied by 2 on numerator and denominator. So minus 2 by 10, 16 by 10. So 14 minus 16 is equal to 2. So minus here. So just cancelling minus 2 on both sides. So 2. So W equal to 1 divided by 280. So in the same way, we find out how to count, find out M. After that, applying the value of M and W in the form, we'll get immediately we get K. So that's the answer. So the same way, just applying W in the value of W. So W equal to 1 by 280. So applying the second equation. So 14M plus 28 divided by, so 28W, W equal to 1 by 280 equal to 1 by 5. So here 1 by 10. So 14M equal to 1 by 5 minus 1 by 10. That is 2 by 10 minus 1 by 10 equal to 1 by 10. So M equal to 1 by 140. Now just replace the values in M and W. So 6M plus 8W. 6M plus 8W. 6 into 1 by 140 plus 8 times 1 by 280 equal to, just cancelling the values, 4 times 140 times. So the denominator is same, therefore 140, here is 6 and here is 4. So 10. So 1 by 14. So 1 by K is 1 by 14. So K is 14 days. So the answer is fourth option. It is any examinations 15 to 20%. The process of the questions is very lengthy. These type of problems, it's a variety of problems. So it's compulsory. So some problems solving in many ways, but the problem is logically, suppose some students is very logically thinking, just adding two things. So 22M plus 40W equal to just 3 by 10. So just compiling this answer and get the answer in 1 by K form, just answering in 40 days. So it's another way. So basic way is it's only for format. So just 8M plus 12W equal to 1 by 10. It's for efficient or part of working 1 per day. It's also part of working per day. So it's the thing for the problem number 6. And the seventh problem, same type of problem, but small level problem. 4 men and 6 women together can complete a work in 8 days. So 4 men plus 6 women can complete work in 8 days. So 1 by 8. One part of work per day, 1 by 8. And also 6 men plus 6 women equal to same work in 1 by 6 days. So per day 1 by 6th part of the work. So how to conclude that? Simple way, just finding M and W. So canceling, just adding, subtracting 2 from 2 to 1. So 4M plus 6W equal to 1 by 8. So therefore, so 6W cancel. So just subtracting. So 2M equal to here 1 by 6 minus 1 by 8 equal to, the LCM is to 24. So 4 times 3 times. So 1 by 24 m. So m equal to 2m equal to 1 by 24, m equal to 1 by 48. So it's for m. So the value of m, just applying in the terms of first equation. So 4 times 1 by 48 plus 6w equal to 1 by 8. So cancelling this value 12. So 6w equal to 1 by 8 minus 1 by 12. So applying the answer is just LCM 24. So 3 times 2 times. So 1 by 24. 6w. So w equal to 1 by 6 into 24. So m is to w. The problem is, what is the ratio of efficiency? So efficiency means this is m and w, efficiency of man and that of a woman. So m is 1 by 48 and the woman is 1 by 6 times 24. So cancelling multiple by 24 on both sides 2 times. So multiple by 2 on both sides. So 1 is to 1 by 3. So multiple by 3 on both sides. So 3 is to 1. So m is to w is 3 is to 1. So answer is 3 is to 1. So the order is very important because the ratio preserve the order. So without order, the ratio is not completed. So the product, the answer is 3 is to 1. So now check the answers. 3 is to 1. So the problem number 8. A can do a piece of work in 10 days. So per day, the part of 1 by 10 part of complete your work. B also per day 1 by 15 part of the work. So in how many days will the work be completed in if they work together? So work together. So A can complete in 10 days. So per day 1 by part of 1 by 10 part of work completed. So also B is per day 1 by 15th part of work. So just adding two numbers. So 3 plus 2, 5. So just 1 by 6. So per day, A and B together. So per day, 1 by 6th part of the work. So completing work is just 6 days. Reciprocal, the reciprocal of the term. So just checking the answer. So the answer is 6 days. Nice, very simple problem. So go to the next problem. A can complete a work in 12 days and B can complete the same work in 15 days. A started a work and B joined him after 4 days. Then they completed the work in together. How many days did B work for? Suppose B work for K days. So B do the working per day is 1 by 15. A per day completing work in 1 by 12. But suppose we assume that B completing the work for K days, then definitely A work for K plus 4 days because the condition is after 4 days. They B joined after him 4 days. So the A is extra 4 days working for the situation. Complete the work is 1. Therefore, the LCM is 60. So just multiply by 5. So 5K plus 20 plus 4K equal to 1. So just multiply on both sides 60. So 9K equal to 9K plus 20 equal to 60. So 9K equal to 40. So K equal to 40 by 9. That is 4 times 9, 40 is 36. And the remaining 4 by 9. So mixed fraction. 4 by 9 days needed. Work for B. So answer is A, first option. So just suppose assume that B work for 4K days, then definitely A work for K plus 4 days because B joined after 4 days. So forming the equation, how part of the work do the work in B per day and also A. So conclude that we'll get the answer. So answer is first option. So next problem actually A can complete a piece of work in 18 days. And B can complete the same work in 24 days. Both of them started a work and A left for 3 days before the completion of work. So in how many days entire work completed? So B worked for all the days, but A worked for first some days, but A left 3 days before the completion of the work. So the forming the equation part is, suppose the entire work completed in K days, then B definitely work for K days. So 1 day work is 1 by 18. So K days work is K by 18. But A is K minus 3 days only, because A left for 3 days before the completion of the work. So B can do the work in 24 days. So 1 by 24 is 1 per day, completing a work in per day. So K days is K by 24. But A can complete the work in K minus 3 days only. But per day is 1 by 8 equal to 1. Just LCM is 72. So multiple by 4. So 4K minus 12 plus here 3. So 3K equal to 1. So 72 on right side goes to right side. So 7K equal minus 12 equal to 72. So 7K equal to 84. So minus 12 goes to right side. So K equal to 12 days. So K means B work for 12 days, but A work for only 9 days. So the question is only for entire completed. So B is entire completed, working for entire work. So the answer is 12 days. So now check the answer. So now the another problem. A work twice as fast as B. That is, A is a fast workman. If they finish the piece of work together in 24 days, then how long will each of them take to complete the work? So now the faster one is A. So A need only less number of days comparatively B. It's the essential thing for the problem. So suppose B need for A need for K days, then B need for 2K days, because A is fast twice as fast as B. So per day is 1 by K plus equal to 24 days work is completed. So per day is 1 by 24. Just adding, immediately get the answer. So answer is K comma 2K, because then how long will each of them take the complete the work? K is take a day, K days completing work, and the 2K is B taking the days. So LCM is 2K. So 2 plus 1, 3 equal to 1 by 24. So just cancelling 2, 12. So K equal to 36. So K equal to 36, 2K equal to 72. So option 3 is answer. So the answer is third option, 36 comma 72. So the next problem. A and B can do a piece of work in 12 days and 24 days respectively. So A can complete a piece of work 12 days, and B can complete a piece of work in 24 days. They work on alternate days starting with A on the first day. So in this situation, we calculate how many work completed in 2 days, because A work for first day, B work for second day, A work for third day. So it's ordering. So now find out 2 days work. So 1 by 12 is the first day work, 1 by 24 is second day work. So adding two terms, 3 by 24 equal to 1 by 8. So 1 by 8 is 2 days work. So another 1 by 8. So how to convert to 1 by 8 equal to 1? So just multiply by 8. So just multiply by 8 in this terms. So we need, here is 1. So just multiply by 8. So just multiply by 8. So 8 into 1 by 8 equal to 1. Here 2 into 8 equal to 16. So 16 days we need. So just alternate days, working for alternate days, then calculate 2 days work. So first day is A and the second day is B, because the problem strongly refer to the person A is started. So 2 days work is 1 by 8. So 2 days is 1 by 8, 4 days 2 by 8, 6 days 3 by 8, and so on. 8 days 8 by 8 is 1 complete work. So next problem is, so the option is 16 days, correct. So the next problem, A and B can piece of work in 15 days and 20 days respectively. Then alternate days starting with A, the first day, how many days is completed? So it's the same problem, but slightly different in previous problem. So find 2 days problem, 2 days completing work. Just take LCM 60, 4 plus 3, 7. So it is 2 days. We need converting this number is 1, but not any integer multiplied by 7 equal to 60, not equal to 60. So 8 times 7 by 60 equal to 56 by 60. So just wait, just the screen is closed. So problem number maybe 13. Yeah, 30. Just to share my screen. Right. Right. Okay. So just calculate 2 days work. So 1 by 15 plus 1 by 20 equal to 7 by 60. So 2 days work. So just multiply by 8, because any integer multiplied by 7 not equal to 60. Therefore less number, less than 60 only for 8. So 8 into 2, 16 days. So it is equal to only for 56 by 60. So remaining part is 4 by 60. 4 by 60 equal to 1 by 15. So 16 days AB, 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 8 pair. But 17th day is again entry in A. So A is 1 by 1 day work is 1 by 15. So remaining is 1 by 15. Therefore 17th day the work is completed. So answer is none of this actually. So 2 days work is 7 by 60. So 56 by 60 is 60 days. So remaining work is 4 by 60 equal to 1 by 15. So 17th day entry in A. So A is 1 day's work is 1 by 15. So 17th day complete the work. So the problem is solved. So the problem, next problem, ABC can do a piece of work in 10 days, 12 days, 15 days, respectively. They worked together and earned 600 rupees, complete the work. So find the earning of B. So A only for 10 days, B only for 12 days, C only for 50 days. So comparatively, A, B, C, A more efficient to B and C. So B normal efficient, C less efficient. Therefore, not compared to days. So efficient means 1 by 10 is to 1 by 12 is to 1 by 15. So just multiply by 60, then the ratios converted to 6 is to 5 is to 4. It's for the efficient for A and B and C. So, but the work is together. So then only find out the efficient part. So now total is 600. Yesterday told that, so 600 is total. Therefore, adding all the terms just 15. But we need only earning of B. So B is 5. So 5. So 1 by 3. Just answer is 200. It's for the problem. So just once again, A, B, C can do a piece of work in 10 days, 12 days, and 15 days, respectively. They worked together and earning 600 rupees for completing work. Find the earning of B. So only for earning of B, then how to find out the efficient of A, B, C? Because working together, separately working, then no problem. 1 by 10, 1 by 12, 1 by 15. But working together, therefore the ratio between A, B, C. So 1 by 10, 1 by 12, 1 by 15, just multiply by 6, because the ratio preserve multiple by any positive integers, no problem. So 1 by 10, 1 by 12, 1 by 15. So implies 6 is to 5 is to 4. Therefore, the earning of B is 5, but 600 equal to 15, because 6 plus 5 plus 4. Therefore, the value is 5 by 15 equal into 600. It's for the answer. So now checking for the answer is okay, nice. So the answer is third one. So 200. So it's for no any formulas in the topic actually. So the time and work part is no need any formulas in mathematically or any other measure. Just you can apply your ideology only for. But the important thing is not confused in days and efficient. So just a person can take more number of days than our then the person's efficient is very less. Suppose a person can complete a work in a few number of days, then the person's efficiency is very large. It's only for important things in the topic. And one more times we we, the, we say the ideology is just M1 D1 H1 divided by W1. It's ideology, and M2 D2 H2 divided by W2. It is for work. It is for employee. So it is for work. It is for employee. It is for days. It is for hours. So it is for another work, maybe another work. Sometimes same work. Same work means same work, then you are not considered the denominator, because W1 equal W2 equal W1, then cancelling the denominator. Just applying the numerator, you will get the answer. So it's only for special topic in time and work, because time and work no need any mathematical formula. Applying for only ideology only. Okay, thank you so much. So now I stop my screen.
Thank you so much, sir.
Thank you, ma'am.
It was a wonderful session to knowing about how to calculate the time work, the basic idea. From the basic idea you have explained, it will be very helpful to the students who are preparing for aptitude test. And also very clearly the technique problems you have given many tips which will be helpful for the students. The 12 minutes calculation we have given shortcut to calculate in very less time. So if they are practicing, their speed will be increasing surely. Thank you on behalf of our institution. Before ending the session, Thanks to our organization to support always to conduct many webinars like this, and also student oriented development program session like this for the benefit of the students. I thanking founder principal Dr. Kuruswani sir, IQSC coordinator Dr. Kushbu Kuruswani ma'am, and all vice principals and HODs coordinators, and also the faculty members who are the back support for conducting this program, and also the SST Edupedia team, Dr. Mr. Deepak Mulpani sir and Mr. Daulat sir, who are always support for conducting the events. Always we will have the moral support from our organization to conduct many webinars. Thank you again, sir, to take part in our SST Edupedia and give your valuable knowledge and many tips to our students. And also it will be live. So any students who are preparing for aptitude skills can use this session. And the topics you have covered is very important. Most of the problem has been covered. So max to max 15 marks they will score from this two session guarantee. So all the best to the students and thank you again for you, sir. Thank you, sir.
Thank you so much for thank you so much